Welcome back. Today we're going to look at a very classical, I would say DFS/backtracking problem called letter combination of a phone number. We're given a string of digits and we want to return a vector of strings. We're also given a very old phone number. We're given a string containing digits from 2 to 9. Both sides are inclusive, and we want to return all the possible letter combinations. So for example, 2 can be mapped into ABC, 3 can be mapped into DF. So a natural way is we need a global variable map to map from those digits to a string of characters. And note that 1 does not map to any letters, so 0 and 1 does not map to any letters. And let's look at one example for digit 2 and 3. 2 can be mapped to ABC. 3 can be mapped to DF. So at the end, we will have 3 by 3, 9 different combinations. And the length of this combination is equal to the length of the digits. So if a digit is empty, we just return this. Let's consider if digits length equals to 0, we just return an empty vector. And yeah, if it's equal to 2, I'll just have A, B, C. So for this case, a natural way is to think at the solution as a space, and we want to traverse from the root, which is at the beginning of the digit. So at the beginning of the digit, for example 2, 3, at first I have nothing, and the first level I have A, B, C, and at the second level for each A I have D, E, F, then for B I also have D, E, F, for C I also have D, F, and by level, and what I need to do is I need to do a DFS for the solution space. We can do this recursively. And normally for this, we define another DFS function. Cool. So the time complexity is going to be 4 to the power of n times n, and the space complexity is going to be O of n, where n is the length of the digit. Okay, cool. Let's start to go ahead with the implementation then. So normally we declare a holder to hold all the answers, and we call this DFS helper function. While we're doing the traverse until it satisfies the condition, we append the current path or the current valid combination to our answer. And of course, we need to pass these digits as well as the index where we have been traversed. And at the end, I will return this solution holder. Even before that, I need to have a map that can map empty, empty. And then for 2, I map ABC. And DF, GHI, JKL, MNO, PQRS, TUV, and for 9 I have WXYZ. So I should have 10 entries, 2, 2, 6, 8, 10. Cool. And yeah, then the main logic lies in the DFS. For this one, I actually don't need to return anything. So within this, I have end condition and I have constraints and explore. For DFS, let's pass by digits, pass by reference to save time and space. Int, we have index, and I have a string current to hold whatever combination right now is, and I also need to pass my answer by reference since we do want to modify this. So if the end condition is meet, we want to push back our current to our answer vector and just return. So what is the end condition? We can either do index, where we can do the length of current equals to the length of digits. Let's just do index. Index equals to digits length. Then means we have hit the end. Constraint and explore. So for each level, let's first take the digit. Int d equals to digits index minus 0, since it's a char. And then I would have the string of chars is going to equal to map d. At this level, I have this many choice. I can just do auto C in chars and push back this current character, keep exploring, and then pop back. This is for backtracking. Since I passed my current by reference, I just continue to do DFS and do the same thing. Just this becomes index plus 1. Yeah. That should be the logic, main logic of this DFS, since we are using the recursion, so the space complexity will, due to the recursion stack, will be O(n). Let's try run the code. Current. Let's claim current. Start with the empty string. Oh. String. Yeah, let's try and submit this one. Cool. So this is a very classical application of DFS, but instead of they give you an explicit tree or graph, it actually, we need to output all the solution in the solution space. We can treat each level as a tree, and we want to explore from the root to from the root node to the leaf node, where this is going to be the end condition to represent the leaf node. Another thing that I briefly want to mention is that for the corner case, for example, if I do not have this thing, then if digit is equal to empty, I'm going to have an empty string, but it makes clear that I just need to return an empty vector. Also, some of the details, like how to handle number characters. If I have a 2 and I want to change this into 2, I can just do -0 character. Yeah, that's pretty much it. Thanks for watching, and I'm looking forward to seeing you guys next time. Bye.